Today, I'm going to solve the simplest quintic equation, x to the fifth power is equal to 1, with the most complex way. And that is the algebra way. I'm not going to use the polar form, sine, cosine, none of that. Just algebra for this. So let's get started. Of course, you can just take the fifth root to both sides and say x is equal to the fifth root of 1. But technically, you only end up with positive 1. And that's the only real solution for this. And in fact, by the fundamental theorem of algebra, we should have a total of 5 solutions up to multiplicity. So, in fact, we have 4 other solutions, and they are just the complex solutions. How do we find it out? Check this out. I'm going to put the 1 to the other side. So we have x to the fifth minus 1 is equal to 0. And because we know 1 is a solution, so we can factor it, and we will end up with x minus 1 times something else. And to figure out the rest, we can just do a quick synthetic division. So I will put that down right here. I'm going to put down 1 x to the fifth, 0x to the fourth, 0x to the third, 0x squared, 0x, and then negative 1 for the constant. Because we're dividing by x minus 1, we are going to put down 1, which is this one right here. Now, bring down the 1 here. Take the 1 times 1, which is 1, and we add them, which is 1. 1 times 1, put it here. 0 plus 1 is 1. 1 times 1 plus 0 is 1. And then do it again. This is a lot of fun right here. And then 1 times 1 is 1, but negative 1 plus 1 is 0. If this right here is a root, this right here should be 0. And this right here will be the coefficients of these. And this right here will be 1 degree less than what we had earlier. It was x to the fifth. Now it will be 1 x to the fourth. And then 1 x to the third. And then x squared, and then x, and then 1. Okay, now this part is not bad, but this part, how do we factor this? This is the quadratic polynomial, and to factor it, yes, it's possible. We can factor it as a product of 2 quadratic, because any polynomial can be factored in terms of linear and quadratic, irreducible quadratic, meaning you cannot factor it without real numbers. Yeah. Anyways, I'm just going to factor it the hardest way because I think that's like the most fair way. So have a look right here. We have x to the fourth plus x cubed plus x squared plus x plus 1 well, let's just factor it. My goal is to factor it as a product of 2 quadratic. So notice here we have x to the fourth, so I'm just going to have x squared times x squared to give us x to the fourth. And then at the end we have positive 1. Of course we can have negative 1 and negative 1, but as you can see everybody right here is positive. So I'm just going to put down plus 1 plus 1. This right here is technically not perfect, but it's just a guess, right? And then I'm just going to put down plus some number a times x, and then plus some number b times x. And then as long as I can figure out a and b, and then I go backwards and make sure that it works, then we are done. To figure this out though, I will just have to multiply this out. So we have x squared times that's x to the fourth. This is plus bx cubed plus x squared. Continue, so it's plus ax cubed plus abx, and then plus ax, and lastly plus x squared plus bx plus 1. So after we collect all the coefficients, this is just x to the fourth. This right here is a plus b x cubed. This right here is plus 1, which is plus 2, and then is ab plus 2. And then x squared, this should have been x squared. And then lastly plus a plus bx. And then lastly, of course, we have the plus 1. Okay, now check this out. We have a plus b. That should be equal to 1. Right, so that's the first condition. And then next, we have this. ab plus 2 has to be equal to this 1. So the second condition, ab plus 2 equals 1. Lastly, ab plus 1 is equal to this 1, which we already have. So we just have to look at these. Not so bad, huh? Now, perhaps I'm just going to isolate the a right here. AB is equal to -1. That will just say b is equal to -1 over a. Put it here. So we are looking at a minus 1 over a is equal to 1. Multiply everybody by a squared minus 1 equals a squared minus a minus 1 equal to 0. So we can use the quadratic formula to figure this out. So a equals negative b, which is -1 here, plus or minus square root of b squared minus 4ac, which is 1 and -1, all over 2 times 1. Okay, so you will see that, in fact, a is equal to 1 plus or minus. This is 1 plus 4, so it's square root of 5, like this, and then all over 2. Now, which one do we take? Or do we take both? Okay, so here is the part that we have to think a little bit. Which one do we take? The answer is it doesn't matter because a and b are symmetric. So here's the deal. If you take the positive for a, then you will figure out b is going to be the negative. If you take the negative for a, then you figure out that b is the positive. So it doesn't matter, right? It doesn't matter. It doesn't matter which one you take for a or b. I will just write this down. If you say a is equal to 1 plus square root of 5 over 2, work this out. b equals -1 over a. You will get 1 minus square root of 5 over 2. If you take a negative here, you get positive right here. And then when you put them back, it really doesn't matter. So that's how you can verify it. So now, this right here becomes x minus 1. And then we can factor it and get this times that. So we have x squared plus a, which is, let's take the plus. So it's 1 plus square root of 5 over 2. And you notice that this right here is in fact the golden ratio. And x plus 1. And then x squared plus b is 1 minus square root of 5 over 2. X plus 1 equal to 0. Okay. Yeah. So now, set this equal to 0, you get x equal to 1. That's first answer. Set this equal to 0, of course we will have to use the quadratic formula for it. I am just going to write this as phi for the golden ratio. So we will get x equals negative b, which is the phi, plus or minus square root of phi squared, minus 4ac, which is just 1 times 1, which is just minus 4 like this, all over 2 times 1, which is just that. Okay? And then that will be the next two answers. And then lastly, I don't know a notation for this thing, but perhaps I'm just going to write it as, because b is just -1 over a, so I will write it as -1 over phi. So this right here is just -1 over phi right here. So we are going to have x equals negative 1 over phi, so it becomes positive 1 over phi. And then plus or minus square root of -1 over phi squared minus 4. 1 times 1 doesn't matter, and then all over 2. So that's that. And in fact, by doing this, you can also figure out sine of 72, which is quite nice. 18 divided by... Yeah. And that's it. That's it.